So this video is going to be straight into the point. We're just going to go over this worksheet and how you predict the different types of reactions. My focus here is mainly on the big ideas of how to predict stuff accurately. Like there's some little finer things that we're not going to get into as much, but for the most part, I just want you to be able to go through and predict these. So you got to identify, to be able to do that, you got to first identify what the reaction type is by looking at it. So like this first one, this is a combustion reaction. All right. We know it's a combustion reaction because we have carbon, hydrogen, plus oxygen. The products are going to be CO2 and H2O. Or you could write it as H2O plus CO2. It doesn't matter. Just simple as that. That's the products of a combustion reaction. You don't need to think too hard about it. We're not going through and balancing these. We're just purely, for the sake of this video and the quickness of it, I'm not bothering having you balance stuff. You just got to do this, identify it, there you go. Now, this next reaction, what's the only thing this could do? So this is magnesium oxide. The only thing it could possibly do is decompose. This is a decomposition reaction. Now, this could split apart into magnesium plus O2. And that's the only thing it could do is split apart just like that. This is written as O2 because oxygen is diatomic. And when something is diatomic, you're going to write it with a 2 after it, just like that. And then you would go back and have to balance it, so you would go in. This one I'll just do real quick. You can do that, put a 2 there, put a 2 there, and you're good. But again, you don't have to balance these. So next, this is a single displacement reaction. So next we have a single displacement reaction. And so again, this one is a single displacement reaction. And again, we're going to identify the charges. So calcium is +2. Copper, in this case, is +2. Chlorine is -1. You can look those up on your ion chart if you need to, or you can just look them up on the periodic table, remember their charges. So in this case, we're going to compare these two. So again, this is a single displacement reaction. Again, I know that because we've got a single element and a compound, and we're going to compare these two things, calcium and copper, and see where they are. So in this case, calcium is higher up on the chart than copper, which is way down here. So that means the single element is higher. All right, it's higher than the one in the compound. That means it's more active. That means it will replace it, and the reaction will go forward. So you will end up with copper being removed. So you'll have copper by itself. So that's Cu plus CaCl2. So the reaction goes forward. Next, we have a double displacement reaction here. All right, where we're going to be looking at, and I know this is double displacement because we have two compounds, and the only thing it could be is double displacement. So you're going to switch the positive charges, so you'll end up with, in this case, you're going to have H and OH combined. When you have H plus OH, just rewrite it as water. Water is always going to be a liquid phase. Then you're going to have aluminum and sulfate, so you'll have it'll be Al2, SO4 with a 3. That's because aluminum is +3, sulfate is -2. So when you crisscross them, you end up with Al2, SO4, 3. So you get that. Next, this is a synthesis. It's the only thing it could be. You'll have bromide form. Next one here. This one would be a little tricky for some of you. I can understand where this could be a problem. The correct answer when you do this, it's going to be hydrogen gas is given off, but then you're also going to have sodium hydroxide formed. It's like a sort of a type of single displacement. If you didn't get that one, fine, don't worry. That one, I probably shouldn't have had that one on there. I'll probably actually go delete it. Since I'm making this before you're actually being assigned it. And then next we've got calcium oxide. This is a synthesis. It's the only thing it could be, so you'll get CaO, and it's just CaO because it's +2, -2. Then single displacement reaction here. We're going to compare these two. So single displacement. So we're going to look up zinc and sodium. So zinc's right here. Sodium is up here, so zinc will remove the sodium, so you'll end up with Na plus ZnOH, and there will be a 2 there because, zinc's plus 2. Hydroxide is minus 1. So then you're going to do this. So this is a double displacement. We know it's a double displacement because you've got, these are both compounds, the H and the mercury are going to switch, so you're going to end up again, this will be just water, liquid water, because H combines with OH. Remember, these are trading. So the Hg and the H3, they're trading. They're not going together. Then you're going to end up with Hg 3 PO4 2. And then if you looked it up on your solubility chart, that would be a solid. This next one, this is combustion. And then we know that because hydrocarbon, oxygen, and then our products are going to be CO2 plus H2O every time. You don't even need to think about it. This next one, single displacement, Al and Feo. So we're going to look this up. Aluminum is right here. Iron is down here. So aluminum is higher than iron. It's going to replace it. So you're going to end up having aluminum replace iron, and you'll end up with Al2O3 plus iron all by itself. And remember, the order doesn't matter. You could flip these. It's the same thing. Then all the last 3 of these are all double displacement. All right, if you look at them all, they're all double displacement. They're all compounds. So you're going to crisscross those. You're going to switch the positives always for all these. So we'll have Si. So we'll have silicon, phosphate. In this case, phosphate is a -3. In this case, silicon's a +4. So you'll crisscross it, and you'll end up, this will be confusing because you'll end up with PO4, 4, silicon 3. And then we'll have calcium oxide. All right, so then you keep going. You got this one. You got iron and potassium. So we'll switch those. So you end up with K2SO4 plus FeOH3. The reasoning that's there. This is iron. This iron is +3. I know that because SO4 is -2, and there's 3 of them for a total of -6. So this 2, it's got to be +3 to cancel that out. And then last but not least, let's look at these again. Oh, that's the exact. Oh, it's almost the exact same one. It's not the exact same one. It's really close. So your first product will be Si3 PO44 plus. In this case, instead of it being calcium oxide, it'll be calcium carbonate, which pretty much is the same thing. So there you go. That's the first sheet. Oh, and then there's this one. This one is decomposition. I forgot there was this last one. This one is decomposition. It's just a hydrogen peroxide breaking down. All right, so it'll break down, and that's fine. What else? And then the rest of these, I don't think the answers were included, so I'll just go through all these too. So you've got FeCl3. Oh yeah, so we'll identify these. So this is double. This next one is single, double, single, double, double. So all right, to go through and just go through these answers really fast for all these examples. So I'm just gonna like write the answers out and you can just watch. I'm not gonna be explaining all these as much. So there's that one. You're just flipping these, double displacement. In this case, we've got aluminum and hydrogen. Hydrogen, if you look it up on the chart, hydrogen is lower than aluminum. So aluminum will replace it. So you end up with H2 by itself plus AlCl3 because aluminum is 3+. This one, you're going to switch those. So you're going to end up with H2O plus calcium phosphate. 3, this will be a 2. So we got calcium and aluminum. In this case, calcium goes to replace aluminum. Calcium is higher on the chart, so the replacement reaction does happen. And a single one of these where the replacement doesn't happen yet. I apologize for that. Normally I like to give you a couple. So there's that. So you're going to switch again. So we got H2CO3 plus that one. And then last but not least, switch those. And this is BaSO4 because they're both positive 2, negative 2. So that's everything. I just wanted you guys to see them written out. I thought that'd be helpful.